Alrighty, folks, welcome to class. Like every day, we're going to start class with a bell ringer. So make sure you have your blue sheets out and take about 2 minutes to work on these two problems. You can pause the video right now. Alrighty, folks, let's go over our answers. Make sure your bell ringer sheets are switched with the person next to you. And we are going to go over what each answer should be. So for the first one, we learned yesterday that angle 1 is going to equal half of the sum of these two chords. So I'm going to take half of 30 plus 112. I'm going to take 30 plus 112, I get 142. And half of 142 is going to be 71. So our answer for our first one should be angle 1 equals 71. For our second one, we learned yesterday that this angle right here, 53, we found that by taking half of our biggest arc, 162, minus our smaller arc, which in this case is our variable. So I'm going to fill in x there, and now I'm going to solve for x. I'm going to take 53 times 2 to get that 1/2 onto the other side. And I get 106 equals 162 minus x. I'll subtract 162 of both sides, and I get negative 56 equals negative x, but I want a positive x, so I'm going to change the signs on both sides. So x equals 56. That's what we should have for number 2. So give your partner an x or give them a circle if they got it right. Trade your papers back and take out your notes. We're going to be talking about segment lengths and circles. And we're going to start with segments of chords. So I'm going to start by reading the theorem, and then we're going to talk about what it means. So our theorem says if two chords intersect in the interior of a circle, then the product of the length of the segments of one chord is equal to the product of the length of the segments of the other chord. So basically what that means is when we have a chord, like we have this chord right here, it's split up into A and B. And then we have another chord that intersects it within the circle, right here within the circle, and it's separated into C and D. So we take our first chord, and we multiply those two segment lengths together, that should equal the segment length of the second chord multiplied together. So let's try that a few times. I'm going to do 1A with you, and then you're going to do 1B on your own. So let's start with 1A. We take a look at our first chord. It's split up into 6 and x. I'm going to say 6 times x. And that's going to be set equal to our second chord, which is split up into 9 and 18. So I'm going to say 9 times 18. So 9 times 18 will give us 162, and that's going to equal 6x. And when I divide both sides by 6, I'm going to get x equals 27. So I want you to repeat that process and try that for 1B. All right, now that you tried that for B, we're going to go over the answer together. So our first segment right here is split up into 14 and x. So 14x on one side, and our other segment is split up into 8 and 20. So I'll have 8 times 20 on the other side. 8 times 20 gives me 160, and that's going to equal 14x. When I divide both sides by 14, I get x equals 11.43. So those were some 2 general applications of this theorem. Let's up it just a little bit more, and we're going to throw in binomials in the mix. So 2x minus 8, that's a binomial. So let's try doing the same thing, but with some harder numbers in there. Our first chord is split up into 5 and 2x minus 8. So I'll take 5 times 2x minus 8. Our other chord is 12 and 4. So that's set equal to 12 times 4. 12 times 4 will give me 48. And on the left side, I'm going to need to distribute. So I'm going to have 10x minus 40 when I distribute that 5. Now I'll move 40 to the other side. And I will get 10x equals 88. When I divide both sides by 10, I'll end with x equals 8.8. Now I want you to try B on your own real quick. So take a second and pause this video to try B on your own. Sweet. Now that you tried B on your own, let's go over the answers. So one of our chords is split up into 24 and x minus 9. So 24 times x minus 9 on one side, and 21 times x minus 5 on the other side. I'm going to have to distribute on both sides now. So on our left side, I'll get 24x minus 216. That'll be equal to 21x minus 105. When I bring 21x over to the other side and 216 over to the other side, I'm going to wind up with 3x equals 111. I'll divide both sides by 3, and x should be 37. So if you did not get that right, take a look at what I did up here on the board and make any corrections on the workpage. We're going to move on to our second theorem for the day, talking about secants. So secants are similar to chords, but instead of stopping at the edge of a circle, it's a line that goes straight through the circle and keeps on going. So this theorem tells us that if two secants share the same endpoint, like these two do, they both end at P, then we can use this formula right here. We take the outside segment of a secant and we multiply it by the whole secant, and that's going to equal the outside segment of the other secant times the whole secant. So we're going to take this equation that we were given and we're going to change it just slightly for our use. So we're still going to say pH times something, but PG is our whole segment, and I'm going to break that apart into pH plus GH. pH is the outside, GH is the inside, and together they make the whole segment. So this is still our outside times our whole segment, just broken up a little bit more. Makes it easier for us to use. And that's going to be set equal to PE, that's the outside of our other segment, times our whole segment is going to be PE plus EF. And it'll make sense why we break it apart this way once we get to our examples here. So you can flip your page over, and we're going to try practicing that one. So if we take a look at 3A, I'm going to highlight the outside of my segments in red. Those are the outside of my segments, and the whole segment I'm going to highlight in this paint color. So our theorem told us that we can take the outside of our segment times our whole segment, which our whole segment of our top secant is 16 plus 32. and I'm going to set that equal to the outside of our other segment times the whole segment, which is 8 plus x. And now I'm going to solve for x. So on the left side, I can do that math in my calculator, and I'm going to wind up with 768. And on the right side, I'm going to need to distribute. So when I distribute that 8, I get 64 plus 8x. And now I'm at a nice, easy equation that I can solve. So I'm going to move 64 to the other side. When I subtract that over, I'll get 704 equals 8x. Divide both sides by 8. And I'll get x equals 88. Now, I want you to try this on your own. It's okay if you make some mistakes because we're going to go over the answer together. But I want you to try it on your own. So pause the video now and try B. Sweet. Now that you've tried B, we're going to go over the answer together. So for our top secant, the outside is 18. Multiply that by the whole thing, which would be 18 plus x. And our bottom secant, the outside is 16. And our whole secant together is 16 plus 24. Now, on the left side, I'm going to need to distribute. So I'm going to distribute that 18, and I'm going to get 324 plus 18x equals, the right side I can do in my calculator, and I'm going to get 640 on this side. When I subtract over 324, I'm going to get 18x equals 316. Divide both sides by 18, and I'll wind up with x equals 17.5 repeating. So if you did not get that answer, take a look at the board, see what you did wrong, and correct anything. We're going to move on to segments of secants and tangents, and this is going to be probably the most complicated we get for the day. So this theorem tells us that if a secant segment and a tangent segment share an endpoint, like these two do right here at E, then the product of the length of the secant segments and its external segments equal the square of the length of the tangent segment. So what that tells us is what this equation tells us right here. So we take our tangent segment and we square it. That's EA squared. And that's going to be set equal to the external part of our secant, that's in pink, times our entire secant. So I'm going to start with 4B, and we're going to do things in a little bit of an out of order place. We're going to do B and then C and come back to A at the end, because A is going to be the most challenging one. So let's start with B. If I scroll up just enough for you to still see that equation, I see that I need to take my tangent segment and square it. My tangent segment is x in this case. So I take x squared and set that equal to the outside of my secant, which is 3, times my entire secant. My entire secant is going to be 30 plus 3, which is 33. When I do that math out, I get x squared equals 99. And when I take the square root of both sides, it's not going to be a nice number. So I'm going to leave it as x equals the square root of 99. And that's my answer. Now, I want you to try C on your own real quick. So take a second and pause this video to try C on your own. All right, now that you tried C, let's go over the answer. So our tangent segment is x, so I'm going to have x squared equals the outside of my secant, which is 9, times my entire secant, which is 9 plus 16. 9 plus 16 will give me 25. When I multiply 9 and 25, I get 225. And that equals x squared. So I square root both sides. And this time I get x equals 15. So if you got that wrong, take a look at the board and see what you did wrong, correct any mistakes. But we're going to go back to 4a and go over how we solve 4a. So like I said, 4a is a bit more complicated than the other two. But we're going to go through it together so that you have an example. Please write this down. I'm not here today, and so having an example of this is going to be crucial for your homework. I think you only have 1 or 2 problems like this on your homework, but you should still have an example written down. So in this case, the outside tangent part is 20. So 20 is what I square. And then the outside of my secant is y. So I take y times our entire secant. Our whole secant is going to be y plus 30. Now the reason this one's more complicated than the others is because when I distribute this, I get y squared plus 30y equals 400. And in this case, I have no way to cancel out the y squared. So I'm going to have to think back to algebra 1, back to the quadratic formula, and we're going to have to use that to solve for y. Now, in order to use the quadratic formula, I need 0 on one side and everything else on the other side. So I'm going to subtract 400 to both sides, and I'm going to wind up with 0 equals y squared plus 30y minus 400. Now, if you get a problem like this and you remember how to factor easily and you want to factor, you can totally do that. I know right away I could factor this into x plus 40 and x minus 10 and set both of those equal to 0 and get x equals negative 40 and x equals positive 10. We take away the negative answer because if we have the length, it has to be positive. And 10 would be our answer. If you can't factor easily, then we need to use the quadratic formula. So we have to go back to negative b plus or minus the square root of b squared minus 4ac all over 2a. I'm going to give us a little bit more room while we keep going. And if we were to fill in those numbers, my b value is going to be 30. My a value is 1 because there's nothing in front of this y, so I put a 1 there. And my c value is negative 400. So when I put this in, I should have negative 30 plus or minus the square root of 30 squared minus 4 times 1 times negative 400 all over 2 times 1. Now, when I solve this, I should wind up with the same answers that I got over here by factoring. So let's take a second and break it apart and solve it. 30 squared is going to give me 900 minus 4 times 1 times Negative 400 gives me negative 1600, so this becomes positive 1600. All right, let's keep going. And we have negative 30 plus or minus still out front, all over 2. If I combine what's inside of the square root, 900 plus 1600, I get 2500. I still have my negative 30 plus or minus all over 2. The square root of 2500 is 50. So this becomes negative 30 plus or minus 50 over 2. And now I can split this up into 2 separate ones. I'll have negative 30 plus 50 over 2 and negative 30 minus 50 over 2. If I work just on my left side one, that's this one right here, negative 30 plus 50 will give me 20 over 2. That's my answer of 10, which we wind up taking as our only answer, because negative 30 minus 50 will give me negative 80. Divided by 2 gives me negative 40. We can't have a negative answer, so this one doesn't work. So our answer for this one is 10. Yes, that was a lot of work, but thank you for writing it down and having the examples earlier. You may start on your My Open Math now. It should be open. It is 10.6. Have a great day, everybody.